Good morning to all. In the previous session, we have studied about the various instruction sets and the various addressing modes that are required for assembly language programs. In today's session, we are going to study about the one more important part which is helpful for assembly language programs, which are called as assembler directives. Assembler directives. So what are these assembler directives? Assembler directives, nothing but it gives the direction to the assembler. So assembler directives are non-executable statements. They are non-executable statements which will give directions to the assembler. So what assembler need to do? Depending upon this assembler directives, the assembler will function. They are non-executable statements. They will not be executed while executing the program. These instructions of microprocessor written in English short form are assembly language instructions, and the corresponding program is called assembly language program. The source program is composed of three types of lines. The program is composed of three types. First one is opcode. Second one is assembler directive, which the machine understands as pseudo opcodes, and the comments. The comments are helpful for the user what the instructions are doing. So the opcode create the instruction for the CPU. Assembler directive gives instruction to the assembler. Comments tells us what the program wants to tell us. Assembler directives are specific for a particular assembler. They are used only during the assembly of program and generate machine executable code. So overview, assembler directives are the directives which gives the direction to the assembler what the program is. So it contains three types of lines. One is opcode, next is assembler directives, and the comments. Opcode nothing but gives the instruction to the assembler. Assembler directive gives the directions to the assembler, and comments tells us what the program wants to tell us. So we have various assemblers, as assembler directives are specific for a certain particular assembler. So we have various assemblers like IBM MASM, which is macro assembler. Second is Intel ASM 86, which is assembler 86, and the third one is TASM, which is turbo assembler. So these three are different assemblers which we can use for our assembly language programming. So I am using in this session EMU 8086, which has been brought by our college, which is also a free source. So anyone can be able to download and anyone can be able to use it and write their program codes and do the execution part. Now we'll see what are the different assembler directives we have. So the first one is assume. So assume means this directive will tell the assembler the name of the which segment it should use for a specified segment. See, as we all know, we have 4 segments, which is code segment, data segment, extra segment and stack segment. So out of this 4 segment, which assembler or which segment the assembler need to use for a specified segment. So for example, if we are writing assume colon cs colon assume cs code ds data. CS code segment we are using as code and DS data segment we are using for data. It is a non-executable statements, right? Next, DB byte. So this directive is used to declare a byte type variable. So we can able to declare a byte type variable with the help of this directive, which is DB. So declare one variable and with DB, and you can store that byte information into that corresponding variable. Next, DD. This directive is used to declare a variable of type double word. Double word, nothing but 32 bits, or to reserve memory locations which can be accessed as type double word. So it reserve memory locations byte, it reserves memory locations double word, and DW, which is defined word, are useful for reserving the memory location of word length, which is 16 bits. Next, ends. It tells the assembler that the corresponding segment is ending. EQU, nothing but equal or given to some value or symbol. It is used to give a name to some value or some symbol. Suppose you need to store a value to corresponding variable, then you can write as n1 equ that corresponding value. Then end, this will be always at the last, which is the last statement of the program. This is to tell that this is the end of the program. End P, this directive tells the assembler that this is the end of the corresponding procedure to the assembler. Extern tells the assembler that the name or labels following the directive are in some other assembly language or assembly module. This can be used when we are using our 8086 processor as maximum mode, where in maximum mode you are giving the powers to the other module. ORG is nothing but originate, nothing but from which location we want to start our code. Macro and end macro, this directive defines the macros in the program. This is one type of procedure, one type of function which can be useful for writing your program in macros, and end macro is to end the macro. So this topic we will discuss in the coming sessions. Now, assembly language programs. So until now, whatever we have studied, the basics requirement for our assembly language programming. So what is assembly language program? A program is nothing but, what is a program? A program is nothing but set of instructions which consists of some set of instructions written sequentially, one below the other, and stored in computers, memory, for execution by microprocessor. A program is nothing but simple, a set of instructions, a series of instructions written one by one and stored in computer's memory for execution by the processor. So instruction consists of mnemonic, opcode, and one or two operands. What is machine language? Machine language understandable by the machine, which consists of only zeros and ones. Assembly language, it uses short form notations called mnemonics to write a program. The mnemonics are like move, add, sub, jump, all the things, instructions that tells what need to do. High level languages, we have C, C++, Java, .NET. It uses directly the English sentences to write a program. What assembler does? It translates assembly language program into machine code. So see here, this is the low level language. Assembly language is a medium level language, and high level language are the absolute high level language. So how it will do? First step is to write a program in an editor. So editor can be a notepad or Word or any other editor, and you need to save that program into as file name .asm with extension .asm. Then assemble it with the help of an assembler. You can use MASM or TASM or ASM86 as we have discussed. So after assembling, it will create an objective file which is file name .obj with the same file name what we have saved. It will create an obj file, object file with the same file name what we have written with .asm. Then after linking the program, it will convert your .obj file into an executable file with the same file name .exe. The same. So how we have done? File name .asm, which will be assembling, creating our .obj. Obj will be given to your linker file. We'll be linking the file as the executable file. If any errors, it will not create any executable file. It will show the errors. After checking the errors, after minimizing the errors, if there are no errors, then it will be able to create an executable file with the same file name. How to write flowcharts, how to draw flowcharts, and what are the representations we need to follow in order to draw the flowcharts for writing a program. So start or end, we have an oval representation to start or end point. So oval will be representing start or end point. Then we have an arrow nothing but it is a connector between one represent to other represent, or one relationship to other relationship, or one representative shape to other representative shapes. For input or output, we have a parallelogram. So parallelogram represents input or output. For rectangle, it represents a process. What it need to do? The process, whether to print, whether to manipulate, all the things will be done if there is a process which is represented with a rectangular box. Decision, if else, all the things we have to write in a rhombus or diamond. A diamond indicates a decision. So rules for assembly language programming we already discussed, but again just an overview. The code must be written in uppercase letters. All the words should be written in uppercase letters. The label must be followed by a colon. For example, label colon. All labels and symbols must begin with a letter. All comments are typed in lowercase. The last line of the program must be ended with the end directive. Thank you.